Hello friends, today we are going to start the topic Roots of Cloud Computing. In this topic, we are going to learn about the roots from which the cloud computing has evolved. We can track the roots of cloud computing by observing the advancement of several technology, especially in hardware. Hardware has virtualization, multi-core chips, internet technologies, web services, service-oriented architecture, Web 2.0, similarly distributed computing, and in distributed computing we have clusters and grid computing, and systems management. Systems management is like the management of autonomic computing, data center automation, etc. The convergence of technological fields that significantly advanced and contributed to the advent of cloud computing can be explained with the help of the figure.
We can see we have four.
We have hardware, internet
मैंने हाथ ऊपर
technology,
किया तो आपको
distributed
वो
computing,
सेंटेंस कंप्लीट
systems
करना है,
management.
बाद में
These
रुकना
are the four
हाथ की
circles
तरफ
we can
देखना नहीं है, कैमरा की तरफ देख के आपको
These are the
sentence
four
complete
circles
करके
we can
ले
figure out in that
आप
particular
अंडरलाइन
diagram.
करो ना, वो
Now
हाईलाइट करो
hardware,
थोड़ा
hardware has this hardware
Back.
virtualization
नहीं नहीं
multi-core
अभी से
chips.
करो
Okay.
Now, internet technologies, it has service-oriented architecture, Web 2.0
In the figure, we can
services,
see that
and
we
then
have
mashups.
hardware, internet
Systems
technology,
management,
distributed
it has
computing,
autonomic computing,
systems
data
management.
center
These are the
automation.
four circles we can.
Distributed computing has utility and
These are
grid
the four
computing.
circles we can
Now,
figure out
when
in that
all
particular
these four
diagram.
sections
Now,
comprises
hardware
and
has this
intersect to a
hardware
point, we get a
virtualization multi-core
technology
chips.
known as cloud
Now,
computing.
internet technologies, it has service-oriented
also say
architecture,
that this
Web
particular
2.0
diagram
services,
explains
and
the
then
convergence of
mashups.
various advanced
Systems
leading
management,
to the
it has
advent of
autonomic
cloud
computing, data center automation. Distributed computing has
Some of these
utility and grid
technologies have
computing.
been tagged as
Now, when
hype
all
in their
these
early
four
stages of
sections
development.
comprises and
However,
intersect
they
to a
later
point,
received
we get a
significant
technology
attention from
known as
academia
cloud
and were
computing.
sanctioned of major industry players.
We can also say that this
Consequently,
particular
a
diagram
specification and
explains the
standardization
convergence
process
of various
followed,
advanced
leading
leading
to the
to the
maturity and
advent
wide
of cloud
adoption.
computing.
Now, the
Some of
emergence
these
of cloud
technologies
computing
have been
itself is
tagged as
closely
hype
linked
in
to
their
the
early
maturity
stages of
such
development.
technologies.
However, they
We
later
present
received
a closer
significant
look at these
attention from
technologies that
academia
form
and
the
were
base
sanctioned
cloud
of
computing,
major
with the
industry
aim of
players.
providing a clearer
Consequently,
picture of
a
the cloud
specification
ecosystem
and
as a whole.
standardization process followed, leading to the
The
maturity and
first
wide
thing from
option.
where the cloud has emerged is from mainframes
Now,
to
the
clouds.
emergence of cloud
Clouds
computing
are the
itself is
technology we're
closely
using
linked
now.
to the maturity of such
This
technologies.
trend is like what
We
occurred
present
about a
a closer
century
look at
ago
these
when
technologies that
factories,
form the
which
base
used
of
to
cloud
generate their
computing,
own
with
electric
the aim
power,
of providing a
realized that
clearer
it was
picture of the
cheaper
cloud
plugging their
ecosystem as
machines
a
into
whole.
the newly formed electric power grid.
The first thing from where the cloud has emerged
Delivered
is
as a
from
utility
mainframes
can be
to
defined
the
as
clouds. The
on-demand
clouds are
delivery
the
of
technologies we are
infrastructure.
using now.
Applications and business
This trend
processes
is
like
like what
security
occurred
grids,
about a century
shareable,
ago when
scalable,
factories
and
which
edge
used to
computer
generate their
environment
own
over the
electric power
internet for a
realized
fee.
that it was
It is
cheaper plugging their
similar
machines
that
into the newly
on-demand, or
formed
we can say
electric
on-demand
power grid.
deployment pay-per-use model. Similarly,
Computing
cloud
delivered
computing
as a
came into
utility can be
existence when we
defined as
have these
on
things.
demand.
From mainframes to cloud can be explained as the old industries or the industries in their earlier times when they used to create their own electricity. Since they create their own electricity, they use it as per the usage, but rest of the electricity which was not consumed. So they decided to rent out or to use the electricity as per the usage from the power grids which manufacture electricity, which is economical as per the usage. Similarly, these days IT companies, they use cloud computing technologies in which they need not to maintain their complete databases. Instead, they can use the services like the platform management, security management, database storage, all these things from the services or the cloud providers who provide these services. This model brings benefits to both consumers and providers of IT services. The on-demand components of this model allows consumers to adapt their IT usage to rapidly increasing or unpredictable computing needs. Providers of IT services achieve better operational costs. Hardware and software infrastructures are built to provide multiple solutions and serve many users, thus increasing efficiency and ultimately leading to faster ROC. ROC or ROI is the return of investment, and as well as the lower total cost of ownership. Total cost of ownership is usually termed as T. In the 1970s, data processing tasks such as payroll automation operated time-shared mainframes as utilities, which could serve dozens of applications and often operated close to the maximum usage of their capacity. In fact, mainframes had to operate at very high utilization rates simply because they were very expensive and costs should be justified by the efficient usage. Like old electricity generation stations which used to power individual factories, computing servers and desktop computers in a modern organization are often underutilized. Since IT infrastructure is configured to handle theoretical demand peaks. Now, as we have discussed earlier, the electricity generation stations, they provide electricity as per the usage of the customer, and the customer pays as per the requirement. He need not to generate his own electricity. In the similar way, the companies which are using these things, or we can say which are using the cloud services, provides the computing servers or the companies the price for the computing servers, only the amount they are using it, or the desktop computers in a modern organizations which are underutilized. So they share the resources to the extensive usage. That means they can use it properly, extensively, and share it with other organizations. So the cost for both the organizations remains effective and need not to pay a huge amount of money. Computing servers and desktop computers in a modern organization are often underutilized. We have discussed this before. And since IT infrastructure is configured to handle theoretical demand peaks, the advent of increasingly fast fiber optics networks has relit the fire, and new technologies for enabling sharing of computing power over great distances have appeared. Now we have the fast fiber optics. Since IT infrastructure is configured to handle theoretical demand peaks, the advent of increasingly fast fiber optics networks has relit the fire, and new technologies for enabling sharing of computing power over great distances have appeared. Now we have the fast fiber optics. Since fast fiber optic networks are there, it has increased the amount of data we can send over the network, or the amount of data that can travel from one place to another. It has increased the speed of the internet, which provides greater utility, or we can say it provides a greater convenience for the companies to transfer data from one place to the another. These facts reveal the potential of delivering computing services with the speed and reliability that businesses enjoy with their local machines. The benefits of economics of scale and high utilization allow providers to offer computing services for a fraction of what it costs for a typical company that generates its own computing power. The second point of the roots of cloud computing are SOA, that is Service Oriented Architecture, Web Services, Web 2.0, and mashups. Since the emergence of web services, or WS, open standards had significantly contributed to the advance in the domain of software integration. Web services can glue together applications running on different messaging platforms, enabling information from one application to be made available to another, and enabling internal application to be made available over the internet. Over the years, a rich web service software stack has been specified and standardized. resulting in a multitude of technologies to describe, compose and orchestrate services, package and transport messages between services, publish and discover services, represent quality of service parameters, and ensure security in the service access. WS standards, or we can say the web service standards, has been created on top of existing ubiquitous technologies such as hypertext transfer protocol and XML, thus providing a common mechanism for delivering services, making them ideal for implementing a service-oriented architecture. The purpose of a service-oriented architecture is to address requirements of loosely coupled, standard-based, and protocol-independent distributed computing. In software-oriented architecture, or we can say in SOA, software resources are packaged as services, which are well-defined, self-contained module that provide standard business functionality and are independent of the state or context of other services. The maturity of web services has enabled the creation of powerful services that can be accessed on demand in a uniform way. While some web services are published with the intent of serving end-user applications, their true power resides in its interface being accessible by other services. An enterprise application that follows the service-oriented architecture paradigm is a collection of services that together perform complex business logic. This concept of gluing services initially focused on the enterprise web, but gained space in the consumer realm as well, especially with the advent of Web 2.0. In the consumer web, information and services may be programmatically aggregated, acting as building blocks of complex compositions called as service mashups. Many service providers such as Amazon, Delicious, Facebook, and Google make their service APIs publicly accessible using standard protocols such as SOAP and REST. Consequently, one can put an idea of a fully functional web application into practice just by gluing process or gluing pieces with few lines of codes. In the software as a service domain, cloud applications can be built as compositions of other services from the same or different providers. Services such user authentication, email, payroll management, and calendars are examples of building blocks that can be reused and combined in a business solution in a case a single ready-made system does not provide all those features. Many building blocks and solutions are now available in public marketplaces. For example, Programmable Web 1 is a public repository of service APIs, and Mashups currently listing thousands of APIs and mashups. Popular APIs such as Google Maps, Flickr, YouTube, Amazon e-commerce, and Twitter, when combined, produce a variety of interesting solutions, from finding video game retailers to weather maps. Similarly, Salesforce.com's offers App Exchange 2, which enables the sharing of solutions developed by third-party developer on top of Salesforce.com companies. The third point in roots of cloud computing is the grid computing. It is the third building block in the cloud computing innovation, or we can say the cloud computing commencing. Grid computing enables aggregation of distributed resources and transparently access to them. Most production grids such as TerraGrid and EGEE seek to share compute and storage resources distributed across different administrative domains, with their focus being speeding up a broad range of scientific applications such as climate modeling, drug design, and such as climate modeling, drug design, and protein analysis. A key aspect of the grid vision realization has been building standard web services based protocols that allowed distributed resources to be discovered, accessed, allocated, monitored, accounted for, and built for, etc., and in general managed as a single virtual system. Consequently, a portability barrier has been present on most grid infrastructures, inhibiting users of adopting grids as utility computing environment. Now here, utility computing environment means pay-per-use computing environment. Inhibiting users of adopting grids as utility computing environments. Here, utility computing environments means the pay-per-use model. Pay-per-use model gives us the flexibility, or gives the companies, IT companies, the flexibility of using as per the requirement. It gives us the elasticity, or we can say the scalability to use as per the requirement. Means if we do not need a complete server or computing storage, we can use it and we can share it at the same time with the other companies or the corporate houses. Next is virtualization technology. Virtualization technology has been identified as the perfect fit to issues that have caused frustrations when using grids, such as hosting many dissimilar software applications on a single physical platform. Here, dissimilar software application means various software applications which are not same in the features, which are operated on different platforms, but we want it to perform the similar task at the particular given environment. Now, virtualization technology helps that perfect solution, or provides that solution which can be used for these dissimilar software applications. In this direction, some research project example is global virtual workspaces aimed at evolving grids to support an additional layer to virtualize computation, storage, and network resources. Now we have to virtualize all these resources for the software, varied software applications that we are using or that we want to deploy over the network. The another point in roots of cloud computing is utility computing. It is the fourth building block for cloud computing. With the increasing popularity and usage, large grid installations have faced new problems, such as excessive spikes in demand for resources coupled with strategic and adversarial behavior by users. Initially, grid resource management techniques did not ensure fair and equitable access to the resources in many systems. These are some concerns while we were working on grid computing. Thus, we came forward for the utility computing, or it has evolved from grid computing to utility computing. The traditional metrics, throughput, waiting time, and slowdown, failed to capture the more subtle requirements of the users. There were no real incentives for users to be flexible about resource requirement or job deadlines, nor provisions to accommodate users with urgent work. In utility computing environments, users assign a utility to their job. Now, utility to their job means they are deciding as per the amount of work they want from that particular provider or that particular server, where utility is a fixed or time-varying valuation that captures various quality of service parameters or quality of service constraints, for example, deadline, importance, satisfaction, etc. The valuation is the amount they are willing to pay a service provider to satisfy their demands. The service providers then attempt to maximize their own utility, where said utility may directly correlate with their profit. Providers can choose to prioritize high yield, that is profit per unit of resource, user jobs, leading to scenario where shared systems are viewed as a marketplace. where users compete for resources based on the perceived utility or value of their jobs. Thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda.